Hi Year 4, hope you're ready to do some more fraction work today. We're going to be adding fractions again, and you did so well yesterday. I don't think our starting question is going to give you too much of a problem. So let's have a look. We haven't got any cake today, we've moved on to donuts, and we've got a group of friends who were trying to add up how much of the bag of donuts they had eaten. Jack ate 2/9, Bethany ate 3/9, and Rio ate 4/9. So how much have they eaten altogether? And how much of the bag is left? Now this is exactly the same kind of problem as we were doing yesterday. So I want you to go away. I want you to model working that one out. Don't panic that there's suddenly 3 fractions in this one when we were only working with 2 yesterday. It's still the same strategy, and we'll have a look at an answer together in just a moment. You go and have a go first. Okay, so let's have a look at that problem together. So we had a group of friends eating a bag of donuts. Jack had eaten 2/9, Bethany ate 3/9, and Rio ate 4/9. So I knew that I needed a model that had 9 parts to it because that is my denominator. Each part representing one of those donuts. And I can quite easily mark on here that Jack had eaten 2/9. There they are. Bethany ate 3/9, 1, 2, and 3. And Rio ate 4/9, 1, 2, 3, 4. So how much have they eaten altogether? Well, I can see here that I have shaded in all 9 parts out of 9. So there's 2 ways you could have written this answer. Both of them are correct. You could have said that they have eaten 9/9, or you could have said that they have eaten 1 bag. 9/9 and 1 whole one are equivalent to one another. And how much the bag is left? Well, there are 0/9 left. There are not any donuts remaining, so there are no parts left to eat. Okay, so let's move on a little bit. Going back just to 2 fractions for a moment. So I know that question had 3, but I want you to have a look at these 2 fractions. When I come to add these together, models are going to be really important for us again. But these are slightly different. Can you see? Start thinking about what happens to the denominator when we add these fractions. What happens to the numerator? Can you spot why these are slightly different? Now, you might want to pause the video and have a go at this yourself. I'm going to show you how I've calculated this. 2 different ways I'm going to show you and what the answer would be. And this shows just how we're going to challenge you a little bit further with adding fractions today. So you may have spotted that if I draw one model with my 9 bars in it, that's not actually going to be enough for me to work out the whole answer. Because here I've got 7/9. 1, 2, 3, 4, 5, 6, 7. And I want to add 4/9 to it. And I haven't got another 4 bars here. So what I'm going to do is I'm going to put my 4/9 over here so you can see. So I have 7 out of 9 parts shaded here. And I have 4 parts out of 9 shaded there. And we can still add those together and come up with an answer. I'm hoping that you're doing that as I'm speaking. So the denominator is still going to be 9. Have you worked out what the numerator is going to be? I hope that you're shouting at the screen that the numerator is going to be 11. So the answer here, when I add 7/9 to 4/9, the answer is 11/9. It's more than 1 whole one. So I've demonstrated it there on 2 separate models. And do it in a slightly different way, which I'm going to show you as well. Still going to get the same answer. So I'm going to show you the 7 ninths. 1, 2, 3, 4, 5, 6. There's my 7 ninths. And I want to add 4 more ninths to it. It's going to carry on filling in this model. 1, 2, 3, 4. Okay, so I've still got the same answer because I have coloured in 11 parts. But I'm just trying to change my pen. 7 ninths and 4 ninths, I have coloured in 11 and my whole is 9. But there is another way of looking at that. I've coloured in the whole of this bar. So I have coloured in one whole bar. And on this side, have a look at how much I have coloured in here. I have coloured in 2 parts out of 9. So this is another way I can record my answer. And these are equivalent. So I could say that 7 ninths at 4 ninths is 11 ninths. That's what we call an improper fraction, because the numerator is bigger than the denominator. Or I can say 7 ninths at 4 ninths is 1 and 2 ninths. And we call this a mixed number because it's a mix of a whole number and a fraction. Okay, so that's what we're going to move on to today. We're still going to need these models, especially at the early part when you're first practicing these. Here are some I want you to have a look at. So some of them have got 2 fractions. Some of them have got 3 fractions, but please don't panic and think, oh, I can't do it. It's got 3 in it, because it's still exactly the same strategy. Draw the models, colour in the parts as you go along. And you can see there are 2 boxes for some of these, because you can write your fraction as an improper fraction, where the numerator is going to be bigger than the denominator. And you can write it as a mixed number, where you end up with a whole and a fraction as well. I want you to go away and have a look at those. Okay, I know this is a bit of a challenge from yesterday, but I also know how great you're going to be, especially if you've got these models. They're going to really, really help you. You don't have to work this out in your head. So go away. I'll work these ones out. You've got these on paper, and then we'll come back together and I'll show you the answers and we can see how you got on. Okay, so that's what I want you to do. Pause the video and go and answer those. I'll see you in a moment. Okay, so let's see how you got along with those. Now, I would be hoping if we were in the classroom and I was walking around and looking at your maths book, I'd be expecting to see some models there that you have drawn to help you calculate those. And if you're getting really, really confident on the next stage, perhaps you are going to start moving away from the models, but I would still be looking for you to be able to explain in words what it is that you are doing. Okay, so just bear that in mind as we move on. But let's have a look. So this is what we were working out. And I'm going to put up some answers for you. So these are the answers to those questions. I'll give you a moment for you to have a look at them. If you've got a different colour pen, then yes, you can mark them yourselves. Now, if you have made an error, I want you to go back and I want you to look at the drawings that you did to see if you can work out for yourself perhaps where it has gone wrong. That's what's really important. It doesn't matter that you've made a mistake. It's recognising where you've made that mistake so that you know you can correct it next time. Okay, so hopefully you've got along okay with those ones and you've written them as improper fractions and mixed numbers, because I'm going to move us along a little bit further now. So here are 2 more sets of activities that I would like you to have a go at. What could the missing numerators be? So I've given you part of a calculation here. You can see the denominator and you can see the answer. But what could be going in these boxes here? And I am looking for 4 different answers. So 4 different ways of making 9 quarters. And then over on this side, we've got some more missing parts of the fraction. So I'm missing a numerator up here. Got the answer, but what would this numerator be to make that number sentence make sense? Here I've got a numerator missing. This is my answer. But 13/9, there's another way we can express that, and that's as a mixed number. It's the same as 1, and how many 9ths would be in there? So as I said earlier, I would be more than happy that you're using a model, a picture for each of those. But if you are feeling really confident and you don't need to, you're working out these mentally, that's great. But if there's an adult with you, I would say to them, just ask, how are you doing it? What's happening to the numerator? What's happening to that denominator? How do you know how to change from an improper fraction to a mixed number? And see if you can explain it. That's the most important thing about being an efficient mathematician, being able to explain your working out and what is happening. So I want you to go and her way and have a look at those. And then finally, you can come back to the video at the end and I'm going to show you those solutions. So I will see you for the final part in just a minute. Okay, so here we go. That was the final part of today's lesson, what I wanted you to do. And I'm going to show you the answers now so that you can check these yourself. So I'm going to put these up. Here are the answers that we were looking for. I should move myself out the way so that you can see those bottom numbers there. Okay, so go through those, see how you have got on. We'd love to hear. Did you get them all right? Were you feeling really wizzy today? Were there a few problems, something you're not sure of? We really need that feedback from you. Okay. I hope you've enjoyed that. Bit of a challenge today, but I think you're more than capable of it. And I'll see you again tomorrow.